Imagine for a moment that Earth is suddenly knocked out of its orbit, ripped away from the sun's gentle pull by a cosmic catastrophe, perhaps a rogue planet passing too close, or a distant star's gravity tugging us off course. Our world would be cast adrift into the endless, cold, interstellar void, alone among the stars. The familiar cycle of day and night would vanish forever, plunging the planet into a strange and eternal twilight. On one hemisphere, people would watch helplessly as the sun shrinks, fading from a blazing disk to a distant cold star. The other side would be plunged into endless, absolute darkness. Temperatures would plummet at a terrifying rate, far faster than any winter we've ever known. Within weeks, the world's surface would freeze solid, locking cities, forests, and oceans beneath a growing shell of ice. Oceans would become miles-thick slabs of ice, expanding outward as the cold deepens. The atmosphere itself would begin to freeze and fall as snow, blanketing the world in a suffocating frost. Only a thin, frigid veil of air would remain, barely enough to breathe, swirling above a silent, frozen wasteland. Life on the surface would perish almost instantly, unable to withstand the relentless cold and darkness. Forests and animals would be entombed in ice, preserved in a world that has become a frozen tomb. Yet, deep beneath the frozen oceans, where sunlight never reached even before, a different story might unfold. The Earth's core would still radiate heat, powering hydrothermal vents on the ocean floor, underwater volcanoes that create pockets of warmth. Around these vents, pockets of liquid water could persist for millennia, defying the frozen world above. Here, in the pitch-black depths, life might continue, strange creatures adapted to darkness and heat, thriving in the last habitable places on Earth. These deep-sea oases could become the final refuge for biology, the last flicker of life on a rogue Earth. This scenario isn't just science fiction. Rogue planets really exist, wandering the galaxy without a star. Our Milky Way is filled with these cosmic wanderers, each one a world adrift in the darkness. Some were cast out by violent gravitational encounters, others may have formed alone, never knowing the warmth of a sun. Astronomers now believe they may be more common than stars themselves, silent witnesses to the chaos and beauty of the cosmos. These lonely worlds drift through the void, each one a mystery waiting to be explored. Studying them opens a window into a new category of existence, planets without suns, and the possibilities they hold. What secrets do these lonely worlds hold, and could life find a way to survive even in the deepest darkness? For decades, the idea of planets without stars seemed like fantasy, but computer simulations in the late 20th century changed everything. These models showed that planetary systems are chaotic, with giant planets flinging smaller worlds into interstellar space. Rogue planets became a predictable outcome, not just a wild theory. Simulations suggested that for every star system, there could be dozens or hundreds of ejected worlds. The galaxy is littered with them. The challenge shifted from imagining them to finding them. How do you detect a cold, dark planet against the blackness of space? The hunt for these hidden worlds would require new tools and new ways of seeing. The search was on. Picture a young solar system, a chaotic arena of forming planets. In this cosmic nursery, planets are born from swirling disks of gas and dust, colliding and merging in a dance of creation and destruction. Gas giants like Jupiter jostle for position, their gravity disrupting everything nearby. These massive planets can dominate their surroundings, pulling smaller objects into their orbits or flinging them away. When two giants cross paths, their gravitational tug can send smaller planets careening off course. These interactions can be violent, with smaller planets being caught in a gravitational crossfire. A close encounter can accelerate a planet to escape velocity, flinging it out of the system forever. This process is like a cosmic slingshot, where the smaller planet gains enough speed to break free from its star's gravitational pull. This is how a planet goes rogue, a cosmic slingshot, a gravitational exile. These rogue planets are cast out into the cold, dark void of interstellar space. Such ejections are common, not rare. In fact, they are a natural part of the chaotic process of planetary formation and evolution. Simulations reveal that many planetary systems lose members this way. Over time, these systems can become more stable as the most disruptive elements are ejected. Our own solar system's stability is the exception, not the rule. The relative calm we experience is a rare gift, in the universe. Many systems may have started with more planets than they have today. The missing ones are the rogues, cast out in the chaos of their youth. The missing ones are the rogues, cast out in the chaos of their youth. These planets wander the galaxy, no longer tethered to a star. These wanderers carry the memory of a sun they can no longer see. They drift through the darkness, silent witnesses to the violent birth of planetary systems. They are silent witnesses to the violent birth of planetary systems. Each rogue planet tells a story of cosmic upheaval and the relentless forces of gravity. The universe is full of these lost worlds. They are more common than we might think, hidden in the vastness of space. Each one tells a story of cosmic upheaval. These planets are the remnants of a chaotic past, drifting through the universe, forever alone. Not all rogue planets are exiles, some are born alone. In the cold depths of space, dense pockets of gas and dust can collapse directly into planet-sized objects. These are not failed stars, but true planets, never bound to a sun. They glow faintly with the heat of their birth, slowly cooling over billions of years. Some massive rogues are too big to have been ejected. They likely formed in isolation. The universe has more than one way to make a world. These orphans remind us of the cosmos's creativity. Finding a rogue planet is a monumental challenge. Traditional exoplanet methods don't work. There's no star to dim or wobble. Astronomers turn to gravitational microlensing. When a rogue planet passes in front of a distant star, its gravity briefly magnifies the star's light. These fleeting brightening events reveal hidden worlds. The duration of the event hints at the planet's mass. Short flickers mean small, planetary objects. Surveys like OGLE have shown that rogue planets are common. Another method: searching for their faint infrared glow. Young, massive rogues retain heat from formation, glowing in infrared, detectable by telescopes like James Webb. Direct imaging finds young giants. Microlensing finds older, smaller rogues. Together, these techniques are mapping the galaxy's hidden population. The hunt is just beginning. Thanks to these groundbreaking methods, rogue planets are no longer just a theory. We've actually found them, scattered like cosmic castaways across the galaxy. These discoveries have transformed our understanding of what's possible in the universe, revealing a hidden population of worlds that drift alone, untethered to any star. Take CHA 1109137734 for example. Discovered in 2004, this mysterious object is about 8 times the mass of Jupiter. What's even more fascinating is that it may have its own disk, a swirling cloud of material that could one day form moons, much like the planets orbiting our sun. It's a miniature solar system, adrift in the darkness. Then there's OGLE 2016 BLG 1928, a planet found using the subtle technique of gravitational microlensing. This world is similar in mass to Earth, a breakthrough that proves even small, rocky planets can become wanderers. It's a reminder that the universe is full of surprises, and that even the tiniest worlds can travel alone. The signal from OGLE 2016 BLG 1928 lasted just 42 minutes, a fleeting, almost ghostly glimpse of a tiny, unseen world passing between us and a distant star. These brief encounters are all we have to study such elusive objects. Another remarkable find is PSO J318522, a young gas giant about 6 times the mass of Jupiter. It glows in infrared, radiating heat left over from its formation, and boasts wild weather. Clouds of molten iron and hot dust swirl through its atmosphere, creating storms unlike anything seen in our solar system. Imagine a world with no sun, yet still alive with storms, and a dynamic, ever-changing atmosphere. These planets challenge our ideas of what a planet can be, and how they might evolve in the cold depths of space. Recent astronomical surveys suggest there could be over 100 billion rogue planets in the Milky Way alone, outnumbering the stars themselves. The galaxy is far more crowded with these hidden wanderers than we ever imagined. These discoveries reveal that rogue planets aren't just rare oddities. They're a fundamental part of our galaxy's story, shaping the evolution of planetary systems everywhere. In fact, they are not rare at all. They are the norm, quietly drifting through the vastness of space, each with its own unique history. Every new rogue planet we find is like adding a piece to the cosmic puzzle, helping us reconstruct the wild and unpredictable history of planetary systems across the galaxy. The census of these wandering worlds is just beginning, and, with each discovery, our picture of the universe grows richer and more complex. Every rogue planet is a clue, a fragment of the galaxy's ancient past, waiting to be uncovered and understood. The universe is teeming with hidden worlds, each one a silent witness to the drama of creation and the mysteries that still await us among the stars. At first glance, rogue planets seem utterly inhospitable, frozen, dark, and lifeless. But life is persistent, and the universe is full of surprises. The key isn't sunlight, but internal heat. A large rocky planet could have a molten core for billions of years, warming a subsurface ocean beneath a thick crust of ice. Around hydrothermal vents, life could thrive, just as it does in Earth's deep oceans. These ecosystems rely on chemosynthesis, not sunlight. A rogue planet could host microbes, maybe even larger organisms, clustered around geothermal oases. Life here would be a world of darkness and pressure, but it could exist. These worlds challenge our assumptions about where life can arise. The ingredients, liquid water, energy, and chemistry, not necessarily a sun. Rogue planets expand our imagination of what's possible. Could Earth ever become a rogue planet? For now, the answer is no. Our solar system is stable. The chaotic days of planetary ejection are long past. Jupiter and the other giants now act as protectors, not threats. Our greatest risk of ejection was billions of years ago, during the solar system's infancy. We survived the chaos and found stability, allowing life to flourish. But our journey with the sun won't last forever. In about 5 billion years, the sun will become a red giant, possibly engulfing or scorching Earth. Our fate is tied to our star, not to the void. Rogue planets remind us of the universe's dynamic nature and the delicate balance that makes our world possible. They are a testament to the wild possibilities of the cosmos.